In this video, we will look at a few facilities associated with char or Java characters. First off, let's talk about casting between char and numeric types. In Java, casting is a process of converting a value from one data type to another. It is essential in situations where types are not compatible with each other but need to interact. There are two main types of casting. One of them is what we call implicit, which is the whitening conversion, and the other one is explicit, which is the narrowing casting. I'll give some examples. Let's say you have an integer x equals 5, and we know that long is a much bigger data type than integer. And by the way, we're talking about primitives here. Let's say long L equals x. Now, this is what we call implicit or widening conversion. Basically, what we're trying to do is integer going into a much larger space. So this is a smaller type to a larger type. This is done automatically by Java. This conversion is safe because Java compiler handles this automatically. There is no risk of data loss. You can think of having a much bigger basket with lots of bits and bytes as the host for storing much smaller data type. So pushing this small amount of data into this larger basket, there will be no data loss. This is safe and implicit, meaning it will be done. There's no compilation error. There's no runtime error. Let's look at these two examples here. Notice that we have this explicit casting. This is explicit. Explicit in the sense that you have to attach a data type in a parentheses to force the conversion. So this is forcing this a, which is a character, into an integer. This is forcing an integer into a char. This type of casting can lead to data loss. So Java requires explicit confirmation. You perform explicit casting by placing the target type in parentheses. Notice that char is of much smaller data type than the integer. So even if you don't have this explicit casting, the conversion of char into integer would have been done implicitly. So this is a safe operation. However, look at option 2. 97 is an integer, and you're trying to cast an integer into a much smaller type, char. So to force this conversion, you'll have to do it explicitly by appending the destination data type inside the parentheses. There's one caveat, and that is 97 in decimal in ASCII table is actually a value of a. This means that there is no narrowing conversion from a big integer into a smaller space. They're simply equivalent when you convert 97 into a char representation. This char representation will simply take you into the ASCII map, mapping 97 to whatever value is associated with 97, which is character A. So if you insist about print line C, you'll get A printed in the console. Let's consult an ASCII table to verify this. Let's look at this chart. On the one hand, we have decimal representation, and the other one is the chart version. The decimal representation for 97 corresponds to a char letter A, and this is the small letter casing A. The capital A is 65. This is the reason when you do C equals 97, or you can cast this to a char, and 97 is a decimal. You get back is corresponding characters on the ASCII table. Notice that this ASCII table only has 127 characters. This table pretty much represents every single characters you see on your keyboard. There's actually another 129 characters in ASCII that you don't see in this table, but those are less common characters. Let's look at some of the operations we can do with Java characters next. Since character could be treated as an integer, and those integers correspond to their ASCII values or an explicit characters, you can use the conditional statements here. In this case, it's a char to double check whether your character falls in between capital A to Z, English alphabet, or whether CH is in between lowercase English alphabet, or whether your CH is simply 0 through 9, a digit. This is a very common way of comparing and testing primitive char. You can also check to see if CH is any other characters as long as these characters fall within ASCII. For example, checking to see if CH is a tab. We note from your ASCII table, tab is sitting inside the apostrophe backslash T. Notice that this backslash is an escape character. The reason why you have this escape character is for your computer to distinguish this tab character against this character T. So even though there are two characters in this, including escape, escape is not part of the character in the context of your ASCII representation. Let's look at some of the other Java native methods that you see in the character class next. Now, we're dealing with the character class. This is not the same as primitive. Whereas with primitive, you can use ASCII comparisons, and they're basically integer comparisons to fetch these characters. But when you push your ch or your character inside a method that is a part of your character class, you can do a lot more. For example, you have these methods calling for isDigit, checking to see if this character is a digit or not. Instead of writing this primitive, checking to see if ch is greater than or equal to 0 and ch is less than or equal to 9, which represents those digits, in a primitive way, you can replace the whole logic with this isDigit method. You can also check to see if a character is a letter or letter of digit, lowercase, uppercase, so on and so forth. These are Java APIs that you would see in a standard SDK documentation. Note the character with the capital C. This is a class in Java. And notice that every single one of these methods requires a char parameter. So you have to send in these ch as an argument to invoke these methods. If you don't have these parameters as input, these method will be rendered useless because it doesn't know what type of characters you're trying to convert into or check. Please go through the whole Java API, and there's plenty of examples on the net that talks about how these are used and how they can be used with more details. This should conclude our discussions on characters in Java.